All right, we are live.
Yeah, with our grand attitude, we're also teaching people that we're not teaching anything, but we're like
No, today we're
exemplifying,
learning multi-category.
exemplifying that we don't understand anything and that it's annoying sometimes.
Learning is annoying, but that's the point. That's
Right?
the point. Exactly what you just said.
That's exactly why you want to do it.
Yes.
Because it's annoying.
Yes. All right. So,
Hi, stuffers. Nick said we need a name for people watching. That's my suggestion. It's not approved. I'm just trying it out.
Approved. The HR department would not approve this. Oh man.
Still considering. I think it's a great choice, but we'll see what comes from it.
Yeah, I don't know. Maybe learners or something. Or
learners.
Maybe give a name to that computer doing that.
What about stuff?
Stuff. Stuff.
So,
all right.
Quick.
What are we doing today, Martin?
What's that? Mood room. How are you feeling today, Nick?
Not great.
Be honest. Not great.
Okay. Pretty terrible.
Right. Same here. So I also can't get warm the whole day. So that's why I'm wearing this very fluffy pullover. So we decided that due to our great mood, we're going to just keep learning ahead because we did such a terrifying job last time on our stream trying to get API keys. So we're just going to move ahead, right?
Yeah, we're just
what you're supposed to do.
Yep, we're just going to keep going.
Close your eyes and keep going, right?
Right, exactly. Yeah, we're going to keep going.
And I have I just came up with a good justification for it, which is that we're just trusting this material. And so far it's always been that if we had just kept reading, everything would have been clear. So let's just pretend that that's the reason.
That's true. This is in the material in Fast AI we trust. Well, in deep learning, what's the course? Practical deep learning for coders.
Deep learning for coders, yes.
In practical deep learning for coders we trust. All right, let's start this.
So here we are, multi-category notebook.
Multi-cat.
This is not about animals, I believe. But who knows? We'll find out.
There will be animals in this. I can guarantee it.
If they aren't, then we're going to put in some. It's just our
100%.
Modus operandi.
There will be animals in this one. Maybe we take this and we do. All right, let's talk about this. What is multi-categorization? What is multi-category labeling?
You want to talk about it?
No. I want to read it.
Okay, good. So we have an understanding here.
Yes.
Go ahead.
Okay.
It's all yours.
All right. So other computer vision problems. In the previous chapter, you learned some important practical techniques for training models in practice. Considerations like selecting learning rates and the number of epochs are very important for getting good results. In this chapter, we're going to look at two other types of computer vision problems: multi-labeling classification and regression. So I'm going to stop there. We're going to separate this into two streams. We're going to do multi-label classification in this one, and then we're going to do regression on Monday. Cool.
Thumbs up.
So the first one is when you want to predict more than one label per image, or sometimes none at all. And the second is when your labels are one of several numbers, a quantity instead of a category. Okay? That's pretty cool. Like how many apples. That's nice. In the process.
Wait, so regression is predicting a quantity instead of a category?
That's what it sounds like. Like a category, but then how many in that category? Right?
It says instead of a category.
When your labels are
category.
And the second is when your labels are one of several numbers, a quantity instead of. Okay, we're gonna do that on Monday, so let's just keep pressing, keep going.
Just something important.
It's astonishing how many ads you've blocked through this browser.
Thank you. Is this a real one, or is this like a fake one? YouTube pronunciation guide.
I think it's pronunciation
category
manual.
The right one or the fake one?
We'll find out.
Well, okay, so this one says category. You probably
so
didn't
that's
hear
incorrect.
it.
Yeah.
You say it's category.
You should go to one that is go to YouTube. Category pronunciation. I think it's pronunciation guide or pronunciation manual.
There's one called pronunciation guide. There's also Emma saying.
All right, maybe they don't have it.
Okay, it's
trying to
fine.
find the fake one. I was trying to find a bad one.
Okay, category. I'm gonna stick with category. Onwards.
Yeah.
Multi-label classification. Okay, so this is part one, multi-label classification. We want to predict more than one label per image or sometimes none at all. 0 to many.
Yeah. I don't think that's what it is, but we'll figure it out on Monday.
We'll see. Multi-label classification refers to the problem of identifying the categories of objects in images that may not contain exactly one type of object. May not contain exactly one type of object. There may be more than one kind of object, or there may be no objects at all in the classes that you are looking for. I see. For instance, this would have been a great approach for a bear classifier. One problem with the bear classifier that rolled out in the diamond brackets was that if a user uploaded something that wasn't any kind of bear, the model would still say it was either a grizzly, black, or teddy bear. It had no ability to predict not a bear at all. In fact, after we have completed this chapter, it would be a great exercise for you to go back to your image classifier application and try to retrain it using the multi-label technique and test it by passing in an image that is not of any of your recognized classes. Sounds good. So that, for example, I'm picking this out of thin air. Thanksgiving. I totally blanking on the name of the bird. What's it called?
Turkey.
Not peacock.
Turkey.
Thank you. So that in case you're trying to classify a turkey, it doesn't tell you that it's a red-bellied woodpecker, for example, if it's just not a turkey.
Yeah, but I still like our version more.
We could go back to change it, but
yeah, we can. All right, that's maybe
in practice. Yeah. No, go ahead.
No, I was gonna say if we could also just put some sort of like a threshold on it, right? Because we're trying to figure out the results. So like for Thursday or last Thursday, we could have just said if it was under a certain threshold,
right,
it was just a turkey. Like everything that's not a bird is a turkey. That
would have worked.
Anyway.
But I wonder whether this is how this does it. That's like the first logical idea I'd have about doing this. You know, if it's like if any class you set some sort of threshold of 80%, I guess, certainty, and if it's not below that, to just say nothing.
Right.
I wonder. We'll see. In practice, we have not seen many.
Well,
yes?
So I think. Yeah. I'm slow today. So I was thinking like it's going to classify it Like, I wonder if it's going to classify this bear or turkey, right? As like, we're going to run it through the model. We're going to see, okay, it's 20% a red-bellied woodpecker.
Mm-hmm.
So you're suggesting that regardless of what it tries to, what it thinks it is, if it's not very confident, it'll just say it's not it, right?
I was wondering whether that's, yeah.
So there's like
It could be one way to approach it.
There, yeah. I have a feeling it's like smarter than that. Like there's smarter things under the hood, but
I think so too.
Yeah. Anyway, okay, continue.
In practice, we have not seen many examples of people training multi-label classifiers for this purpose, but we very often see both users and developers complaining about this problem. It appears that this simple solution is not at all widely understood or appreciated, because in practice it is probably more common to have some images with 0 matches or more than 1 match. We should probably expect in practice that multi-label classifiers are more widely applicable than single-label classifiers. First, let's see what a multi-labeled dataset looks like, then we'll explain how to get it ready for our model. You'll see that the architecture of the model does not change from the last chapter, only the loss function does. Let's start with the data. Hit it, Nick.
Okay, for our example, we are going to use the Pascal dataset, which can have more than one kind of classified object per image. We begin by downloading and extracting the dataset as per usual. Let's click that.
What's the Pascal dataset?
Dataset is different from the ones we've seen before in that it is not structured by file name or folder, but instead comes with a CSV telling us what labels to use for each image. We can inspect the CSV by reading it into a Pandas data frame. Okay, so whenever that's done.
Cool. Look at this sneaky anti-data function just working in the prepared examples.
Right.
Still doing something here. I double checked that we're on a GPU.
Nice. Nice.
Slowly learning. Slowly.
It's a process.
Okay, so here this is what it looks like. We got rows with file names. What it is valid. Okay. Seems like something.
I don't know what a horse person is.
Yeah, right. We're looking at that. Yeah, all right. But in all reality, I think you're right. It's probably 2 things in the image, right?
I don't know. But we will find out.
We'll find out.
So as you can see, the list of categories in each image is shown as a space delimited string. Okay, so I guess we just found out.
We did not actually see that, but that's okay. It could have been comma separated. All right, sidebar. It's over there. Pandas and DataFrames. No, it's not actually a panda. This is just not funny because we're in a bad mood, or
I think we're just in a bad mood. Yeah. I think we're just in.
Yeah, I can see. I would make like a little panda symbol here at other days, or 5. Not today. No, it's actually it's not a panda. Pandas is a Python library, we know that is used to manipulate and analyze tabular and time series data. The main class is a data frame, which represents a table of rows and columns. You can get a data frame from a CSV file, a database table, Python dictionaries, and many other sources. In Jupyter, a data frame is output as a formatted table, as shown here. You can access rows and columns of a data frame with the ilog property as if it were a matrix. True. That's interesting to think about, that this is the same way that we work with tensors, right?
Mm-hmm.
Like row, column, I guess. Row saying all of the rows from start to finish, and the first column, which is the file names. And this gives us the first row, I guess. Trailing columns are always optional in NumPy, PyTorch, Pandas, etc. So this is equivalent to just getting the first one. File name 5 JPEG chair true object. You can also grab a column by name by indexing into a data frame directly. Data frame file name. Okay, yeah. So we know that. Did you work a little with pandas, Nick? Or is this new stuff for you?
You know, if I feel like I did years ago, but you know, if you don't work on it for 4 or 5 years.
Is that similar syntax to Go, or like would you index like that?
In
I don't know. It's...
like in a
I mean, I guess it doesn't have a like a table structure or something. Should I just not ask you anything? Let's keep going. You can create new columns.
Let's keep going.
And do calculations.
Well, so like
forget that this happened.
Well, no, like if you wanted,
thing happened.
I don't know what like the equivalent to data frame would be in Go. Like you could create your own custom type or whatever, but like if you wanted to grab it from like a dictionary or something, yeah, you could do this. Like you're just you're looking it up by the key, right?
Right, yeah. And then it just says that the column name is the key for all the values in the column. Essentially, is how it treats it. If you think from a Python point of view, is what I wanted to say. Then yes, this is exactly a dictionary syntax. You'd access the value of the key f name like that, but then so this just treats like all values of one column as I guess
there's
as
like
values to the key of the name.
Right, there's like just a data structure within that key, but
yeah, it's like a
I don't know. My brain's not
at least
working.
I think it's like it's a series object, I believe.
It's
if we're technical about it, it's a pandas series object, I believe. Yeah. Oops.
Yeah, my brain's not firing on all cylinders this morning, so I'm just gonna say any difficult questions or any easy questions, don't even ask.
I'm gonna direct them
to the internet,
towards the sky.
Yes,
or to the internet. You can create new columns and do calculations using columns. We are making a temporary data frame, I believe, and it's just gonna have 2 columns and 2 rows. Go ahead. I'm gonna get rid of those outputs. Clear output, so that we. Alright, that's enough. What?
So we're surprised.
I thought there's gonna be more. Yeah. Yeah. So to have a bit of, a little bit of the magic. You don't want to already know what's gonna happen. All right, temporary data frame C. So what we're doing here is creating a new column called C, and it's gonna be each row of the other 2 columns added to each other. So 1 plus 3, so this is gonna be 4, and this is gonna be 6. Or it's gonna be in a new column. Wow. Okay. Pandas is a fast and flexible library and an important part of every data scientist's Python toolbox. Unfortunately, its API can be rather confusing and surprising, so it takes a while to get familiar with it. If you haven't used Pandas before, I would suggest going through a tutorial. We are particularly fond of the book Python for Data Analysis by Wes McKinney, the creator of Pandas. It also covers other important libraries like matplotlib and NumPy. We will try to briefly describe Pandas functionality we use as we come across it, but will not go into the level of detail of McKinney's book. Cool. Now that we have seen what the data looks like, let's make it ready for model training. All for you.
Okay. Constructing a data block. How do we convert from a data frame object to a data loaders object? We generally suggest using the DataBlock API for creating data loaders object where possible, since it provides a good mix of flexibility and simplicity. Here we will show you the steps that we take to use the DataBlocks API to construct the data loaders object in practice, using this dataset as an example. As we have seen, PyTorch and FastAI have two main classes for representing and accessing a training set or a validation set. Dataset, a collection that returns a tuple or tuple, depending on who you are, of your independent and dependent variable for a single item, and a data loader, an iterator that... Yes? Oh, you had your hands up.
I was just...
Oh, okay.
I was just...
making...
I was making a tuple with two items.
Oh, I thought it was a tuple. An iterator... data
no,
loader.
it's a tuple, yeah.
Okay.
That was confusing. I'm sorry. Yeah. Should have been more clear about that.
Right. A data loader, an iterator that provides a stream of mini batches where each mini batch is a tuple of a batch of independent variables and a batch of dependent variables. So can you scroll a little bit?
Yeah.
On these types, FastAI provides two classes for bringing your training and validation sets together. Can you scroll back
on
down?
top of these? Down? Up?
Yeah, go back. So, hold on. As we've seen, PyTorch and FastAI have two main classes. Okay. Data sets, an object that contains a training data set and a validation data set. Okay. And data loader is an object that contains a training data loader and validation data loader. Since a data loader builds on top of a data set and adds additional functionality to it, collating multiple items into a mini batch, it's often easiest to start by creating and testing data sets and then look at data loaders after that's working. So,
okay.
Let me just read that last sentence.
Sure.
Again. Since a data loader builds on top of a data set and adds additional functionality, collating multiple items into a mini batch, it's often easiest to start by creating and testing data sets and then look at data loaders after that's working. All right. Whatever.
Okay. It's just saying start with the simpler one, like start with the more basic one, get it to work, move on to the one that is built from the simpler ones.
Yeah. All right. When we create a data block, we build up gradually, step by step, and use the notebook to check our data along the way. This is a great way to make sure that you maintain momentum as you are coding and that you keep an eye out for any problems. It's easy to debug because you know that if a problem arises, it is in the line of code you just typed. Okay, let's start with the simplest case. Doesn't it feel like we're going backwards? Or did we just never cover this?
Excuse me. I think we tried to go a little bit into data blocks ourselves I don't think there was a lot of explanation about them lower level. But yes, I think we're looping. I think it's probably built in a way that we touch on some topics a couple of times. What you listening to?
Regs is in the corner. What's up, baby?
Oh, he's not?
He was listening to like the floorboards. And I think somebody in the hallway is like sweeping or scratching the floor.
Maybe someone is trying to get into your flat from the floorboards under the floor.
If they do, I hope they do it on the stream. That would be kind of cool.
Right? Turning up suddenly.
The Kool-Aid man blasting through the wall.
I don't know who that is.
Yeah,
that's okay.
It's okay. It's all right. Yeah, doesn't it feel like did you answer that question already?
Yeah, I did.
All right, moving on.
You can watch it under record.
Yeah, I'm time stamping this one, so yeah. All right, so let's run that. Can you run that? Sure. We can create a datasets object from this. The only thing we need is a source. In this case, our data frame. Okay.
Data block. Okay, so we make an empty data block and then make a data set out of the data block by passing in some something.
We make a data set from the data block by passing in a data frame.
Mm-hmm. I assume we could have made a data block with value also here, right? A data block and pass in data frame, maybe. Do you want to try that?
I don't know, because it's...
Well, you cannot stop me.
This is true. Just do the double question marks.
Could do that, but it's more fun like that, right?
Yeah. Go for it. I can't stop you anyway.
Right. So it worked. What are you? Data block. It's a data block. Data block dot. Yep, it's got all sorts of things.
Can you do like dtry set?
There's a data set. I don't think there's a set.
No. I'm saying create a different variable. Call like dtry set or something. dset try. I don't know. It's just something different. Okay, dset is fine.
It's different.
And then do dtry.datasets. And can you compare
Okay.
dset and dsets?
See what you're trying here.
Ooh, missing a source. So it doesn't seem like it can get it from the data block. Unless there's a different way of doing it.
Yeah. Good try.
Which, if you did pass the data frame into that, I wonder how, like what's happening right now? What is this dtry data block?
As opposed to,
As opposed to like the
what's
null or, nil one above.
empty.
Right.
Yeah, it might be filled. Okay, so this is enough. I'm gonna do what you suggested. Hello. Data block. So class generic container to quickly build data sets and data loaders. So did we build a data set or a data loader? We built a data set. Okay. They told us the data set is the more simple one. Get X, get Y, get X. So it seems like we passed in. Wait, where's init? Doesn't even have an init.
It's right there.
Where?
You're highlighted.
There it is. You're right. Yeah. Okay, I see. So blocks. Okay, so we're passing in. This is what we gave it. Blocks. Whatever blocks is. It's a list self.blocks if blocks is none else blocks. Self.blocks. Assign it to itself if it doesn't exist. Like, so if nothing is passed, otherwise assign it to whatever comes in.
Okay.
So blocks. And then it does another blocks. If callable, else b for being blocks. Call something if whatever is in there is callable. Otherwise, just return the items. So I guess maybe there's like you could pass something in that needs to be called to actually create data or something. And this does is when you initialize it.
Okay.
Could be. And then there's more. But we don't want to, right?
Yeah, I don't think we really care about the more right now.
I'm gonna give it one more thing here, just to see what it says about the variables we're passing. Yeah, generic container to quickly build datasets and data loaders. Okay, data block dot data sets, data loaders. What we got here? Source. So here we're giving a source. And then I think the data sets probably takes the same because that's what we did before. Source. Cool. I am ready to move on.
Cool. Okay, so we just created data sets. This contains a train and valid data set, which we can index into length dsets.train. Okay. So we got,
Nice.
yeah.
So this is, it's pretty cool, right? So it finds, how does it even know what's train and what's,
I think
right.
if you go up,
No,
it's
it
in that
doesn't.
CSV.
It just splits it.
Well, no, if you
No, I think it just splits it. How would it know what's, like, it doesn't matter what's training it
sure it does.
and validation set. I don't think that's predefined in the dataset. The dataset is just a dataset.
No. Scroll up. Keep going. Right, go back down. Right there. Is valid. So is a validation versus is training, no? So the car.
I thought it's like, yeah, you're right. I thought this is just, it's not a good picture of a car, or it's like, but why would it be in there?
That one's so actually a turkey.
So it's not, it's not about whether it's valid or not. It's whether it's validation set or not.
That's what I can think of. If like they're splitting it and you're providing the CSV, then it would make sense that you're doing it.
It would make sense.
Way.
It could also just be that it applies a 80-20 split by default, and it just takes a random 20% of the data for validation.
Sure.
But yeah, I think you're probably right.
And then your theory would be true, where it's actually not a photo of a car.
Yeah.
But it's interesting, right? Because like if it's not a photo of a car, then is valid could be part of. Well, no, because then.
Does that work?
Nope. In the validation set, do you have images that are not what their labels are? Like, would you put a car in a validate, like that car, right? Would you?
I'm not really listening to you because I'm playing around with some Panda stuff that I don't remember.
It's fine. I'm kind of just like, I wasn't really talking to you. Okay. I was talking to our audience of, no, because I'm thinking like, can you not just open that?
It looks like.
Didn't we download this file? Didn't we download all these photos? Can you just not open up 12.jpg and see if it's a car?
I'm not sure. Maybe
end all of this.
Let's end it. But where? Okay, so where is it though? Where did it untar it into?
I don't know.
Path. I guess it's in path probably. So yeah, we should be able to open it. But it looks to me that there's 2,500 true values, so it's about half. Would it be half for validation? And
no, because at the bottom it said it was split like 4,000 were training, which goes to that 80-20 that you were suggesting. So now I wonder what is valid actually mean. It could be that if we read.
Let's see.
Yeah,
it's probably,
further,
but
we'll
train.json, test.json.
Hey, Martin.
Yeah?
Do you think if we read a little bit further, we'll get the answer? Just wondering.
I think you're probably right.
Okay, but we're going to continue on this, right?
I mean, that's what we do, right?
Yep.
So we got a train folder. We got a test CSV, train CSV, segmentation folder.
Oh, wow. There's a lot here.
And we got a test folder and a train folder. And then a couple of JSON files. So let's see what's inside of path. What's inside of train. Does that work? Can I do this, Nick?
I don't know.
Me neither.
Wow, that was surprising.
Sometimes it works. Look, so here's pictures in there.
So story of our stream.
So here I could try to see whether 0, 0, 1, 2, 3, 4, 12 JPEG is in there, and image open. Is there something like that? I think there was something like that, but I forgot what it was. Image display. Let's try. Yeah, that wasn't it. How was
Can you just copy that and then open it with like...
I don't know where it would open it. Like we want to display it inside of the notebook, right?
Yeah. You don't think Bash would open it in the notebook? You think it would open it on some sort of like Google Colab server and stay there forever?
I have no idea, but it sounds like an interesting thing to try out. What Bash would do. Command not found is what it would do.
Yeah, I don't think it's open in Linux. I think it's
Oh yeah.
I don't know what it is. Unless they're running like a very specific flavor that...
We should just be able to see it here, right?
It's in the dot folder.
Yeah, right.
Well, can you just click on that? Hold on. Hover over. You just, and then, yeah. Command click.
Could not find. Could not fetch. So maybe it's not inside. So let's try one more thing here, which would be, because this is the one that's false here. So we can check out the horse person maybe.
Are these valid paths, or is this just generating a path? Like, is that actually true?
Oh, no, I don't know that. We don't know that.
We don't know where it actually is. Okay.
Okay, so this exists.
Interesting, okay.
So I can try 09, and then, how was it? I just hovered?
Yeah.
Now we need to run it. Did I hover here?
Yeah.
Or did I hover over there?
No, just hover over and wait. Yeah,
there it is.
Can I find it? Interesting.
So it does exist in there, but now I'm actually also interested whether the 12 one exists also. So they're both in the train folder.
Can you change?
I'm just checking whether I'm... Okay, yeah.
Okay.
So both of them are in the training folder.
Uh-huh.
Which does that make sense with the validation? Is that part of training?
Validation, part of training.
Because you have, right, you have the test data set, which is different than the validation data set. So I think the validation would be part of the training. Which would make sense then.
Yeah.
But let's just, how do you open? This is ridiculous. I just want to know how to open a 6. Oh my God, look at this number. How to open a file. Open image file fast AI. No forum. Be nice to me. When are images loaded? They're all way too smart. Look, they ask all these good questions. Yes, this is what I want. Open _ image. Thank you. It can't be so difficult, right? Open _ image. Passing in a path. No.
Try, open file.
Open file. Let's do it. Text IO wrapper. Mode read. So now we opened the file. I hope it's that's just Python opening a file, like so that we can edit it. That's not actually what we want to do. I hope it closed it. Otherwise, I'm gonna have to close it. Close file. No.
Oops.
It's probably it's probably a text thingy, context. This guy, Nick. We gotta know how to open an image. I think we did that already a couple of times. All right.
There's got to be like another way of doing it within Jupyter, right?
Yeah. how is it? Pill open image with PIL. Image.open. Okay, so we have to make an image object and then do image.open. That should be doable. Image. Okay, and then yes, and then im.open. No. Module object is not callable. Module PL. Do you have some better input than what I'm doing here?
Yeah.
Yes?
Yeah, let me
hit it.
Let me send it to you.
pl.image.open opens an interface to give an image file. Okay. That should work then, from my understanding. What are you? pl.image.open like that. Ah,
nice.
That's a car.
That is a car.
I think that's a car. So that's a horse and a person. I would argue it's a horse person.
I would as well. That is definitely a horse person.
Horse person, huh?
Okay.
All right. So conclusion, it's a horse person. Okay, so this works. I think there's a much easier way to do it from within FastAI, but whatever. Okay, so what did this tell us? That this probably means it's validation. It's part of all of those true things are part of the validation data set, and all of the false ones, which seem to be about half, are part of the training. Does that make sense?
I wasn't paying attention.
Right.
But it probably did.
Onwards, ho.
You're a smart cookie, Martin.
Onwards, ho.
Okay. All right.
DataBlock, data try. Here we are. This contains a train and a valid data set. But now it tells us that it's 4,000. That makes much more sense, yeah? That it's 4,000 that are training and 1,000 that are validation.
Yeah, that's what I was saying. Why? 80-20 rule.
I'm sorry, Nick. I have to do this. I don't know why. .unique. Pandas series .unique. I thought that's what I did. Account. Unique account. Is it just unique account? Educative. Create value counts. That's it. I remember. F at is valid value counts. Hit it. Totally. Look at that. Nick, I can say some things. I'm not randomly typing stuff or looking things up.
I was reading a magazine.
That's good. That's good. It's good that you're educating yourself. Learning something.
Learning about safe diving.
Important.
Yes. I'm going diving on Sunday.
Oh,
Not
nice.
that, anyone cares, but yeah, to like a new spot. I'm on this like exploration kick. I just want to go anywhere there's water. Just get in, and if somebody comes and says I can't do it, so be it. Anyway, continue.
You're not going to disturb some undisturbed wildlife.
No, I don't think so.
What is this? What is this all about? Okay, so
You look like you're in an interrogation room. For a moment, it was like, yeah.
no. So I admit everything.
Is
It's
that a horse?
2510.
Is it a horse person?
It's a horse person.
Is it a horse person?
It really is. Please stop this.
I'm surprised more people don't watch our stream.
It
has like moments of entertainment.
If you manage to sit through all the failure.
Ooh. Maybe we should just invite our parents on the stream. They've endured the failure for so many more years. All right. So
look what I found.
Okay.
Indeed, this is valid, is split 50-50.
Yep.
So why? And then, but if we, so it seems that at least it's maybe doesn't even do anything with this is valid. Mm-hmm. Like it's not choosing them according to that, because the way that FastAI splits it up is some sort of 80-20 thingy, 4,000 to 1,000.
Do you have gain on your mic? Is there a gain knob?
Maybe. What's gain?
Maybe, I don't know. No, you're just like coming in very like what's the technique, like it's clipping, the audio is clipping. It's just very like loud is not the right word. Like you're loud into the mic, and then the mic is not, it's like it's not grabbing everything. You're you can change the input amount.
Think it helps?
That's I think you should stay like yeah. Now your voice is bouncing around the room and then going into the mic.
Great. I could also have this lamp like redirect my voice into the microphone like this.
That's very
I could speak like that. Is that good? How's the audio quality if I do that?
It's actually much better.
Oh, all right, great. So we just continue.
No,
I just
it's
don't
back.
see what I'm
It's back.
Because I turned my head too much. So like this is good.
I wonder if there's anything I can do on my side to change your audio.
Why? I think that's a great solution.
Oh, if you talk into the light. Yeah. No, yeah. Keep talking into the light.
Okay. I just need to still see what's going on. Wait, let me get that fixed. How's that? Is that better?
It's actually worse. Oh man. Oh, that's gonna get warm. That's how you should warm yourself up.
Oh my god, it's really warm.
That's how you get straight hair.
Sorry.
On the top of your head only.
I'm actually warm, so let's take a short break from our intense content here so that I can take off my pullover.
All right. Yeah, I think you should also just
wait, I didn't hear you, obviously.
All right, go take off your pullover. I'm gonna go back to my magazine.
Okay, see ya. All right, I'm back.
Welcome back.
Gain. Thank you.
Yeah, you can lower your input volume.
Okay, I think I can do that. Yeah. What about this? Oh no, that's just how loud it is. That's just for the loudspeakers. Up.
Are you in the chat?
No.
We have.
Oh, there's someone chatting. You can change the input amount, upper right hand.
On your screen.
Ah, true. Where is that?
I think they're right there.
Here. Headphones.
Sound
output.
preferences.
That's just the output.
Open up sound preferences.
I'm doing it. All right, thanks. Thanks, Vice Rest.
And then input.
All right, so input. I hear.
There you
And
go.
then this is very loud, yeah.
Uh,
But it's not showing the right. So this one. Okay, there you go. So it's about mid.
yeah,
And I
so
should put
lower
that
it,
down.
raise it
Is that better?
3/4 of the way.
Like this?
Yeah, but like get excited about images and stuff again like you were before.
I'm super excited.
I think that's better.
Wow. Yeah. Don't have to make me. You don't have to make me do that. Okay. That's better. Yes.
Yeah, that's better.
Gain.
Yeah.
It was a gain. Great. Okay.
Cool.
So.
Okay, so df is valid. What's happening? Okay, we did this. We got half true, half false.
Yeah.
We still don't know what it is valid.
Right. It's still confusing.
I really think as we go down,
it's definitely going to be explained. Yeah.
100%. Yeah.
100%.
Oh, wow.
It was a person bicycle.
Person bicycle.
All right. All right. So 100%. Let's trust it. All right. Thanks for the audio help. So, do you want to do this?
Did you write this or no? This was here.
No, it was there.
XY dsets.train.
No, wait. Let me. I'm gonna clear the output.
Oh yeah.
So
Let me close my eyes really quick.
Yeah, you close your eyes for a second. Wait, there's like a couple more outputs.
Okay. Oops. I'm getting excited. I'm gonna cover the screen so people can't see either.
I'm not sure that's how it works.
No? Okay.
All right, we're good. XY. So we're picking out. Okay, I think I know what we're doing. We're picking out
in
from
the training set, the first X and Y.
And one should be the data and one should be the label. So let's see. Where's the first one? This is the. It's printing both X and Y. I currently just see one object. Where's the comma? This looks like one object, right?
So if we split by f name, it's after d type object and then f name 8663. It looks like it's just printing two of the same. Yeah.
Uh-huh.
Yeah. So as you can see, the simply returns a row of the data frame twice. This is because by default, the data block assumes we have two things, input and target. We're going to need to grab an appropriate field from the data frame, which we can do by passing getX and getY functions.
So currently we're getting 2 times the same thing. Now we have to say X should be the image file and Y should be the label. Is that, I'm understanding it?
We have two things, input and target.
Yeah, F name and label. It looks like we're just not going to use this is valid.
I don't think so. I think
we're getting rid of it.
I think it's a valid label. I just think we're not using it right now. All right, let's run that.
X at F name is going to be that value. So that's like and then we want to pass in get the X by applying anonymous function where you always pick out the value under F name. And for the label, always do the same thing with the label.
Cool.
Aeroplane. Cool. Yes, why not? Interesting that it flipped it around, huh? It's a different.
Oh, it's a different image. Yeah.
0 is a different image now than it was before.
And it's on the same training?
Yeah. It's train and it's 0.
Oh, interesting.
But it's a different one.
Okay, so as you can see, rather than defining a function in the usual way, we're using Python's lambda keyword. This is just a shortcut for defining and then referring to a function. Yeah. The following more verbose approach is identical. Yeah, okay, so we're defining
and you could even
functions.
Make it more.
Whoa.
They're doing
Look
fun
at you
things
cleaning
like
it
that.
up. Yeah.
If we're ready. yeah. But anyways,
Lambda functions are great for quick iterating, but they are not compatible with serialization. So we advise you to use the more verbose approach if you want to export your learner after training. Lambdas are fine if you are just experimenting. We can see that the independent variables will need to be converted into a complete path so that we can open it as an image. And the dependent variable will need to be split on the space character, which is the default Python split function. Okay, so we can, so it becomes a list.
Cool. That makes sense. So we want to add the path variable that's sitting in here just as a global object and points to where we're starting. This is what we tried before, right? Like we went into path train and then the file names.
So here we're getting the file names from train, and that's going to be X, and then get Y is splitting the label. So now we're going to get a list returned of horse, comma person.
Yes.
Comma children.
Correct.
Comma spear. Or
horse.
What's
horse
the
person children spear?
What's the
cane.
sword? Is it called a cane?
No, I don't think
jousting? Jousting cane? I don't know.
Is jousting the word for that?
When the two horses go like, yeah. Jousting.
Then maybe it's a joust.
I think a joust is the match. Like we're going to joust.
All right, so I think that warrants a detour.
I think so too. Jousting cane.
Jousting weapon name. Jousting weapons.
The lance.
Lance, of course.
But there are different ones. I've seen joust where they have that like ball and they try to like get each other differently.
The swinging ball with the spikes.
Yeah. So instead of
that's all jousting.
No, I think it's just the lance. I think is okay. Then they have a sword.
The mace. That's the one.
A mace, is that the swinging ball?
Yeah.
Nice.
I guess there it is.
Yeah.
It doesn't. Maybe
So
it doesn't
it's
always
different.
swing, but that one seems to be swingy.
Yeah, I know a mace as the second one, the one
This,
or
yeah.
the right.
This one, right?
No.
Oh, it's a product. You can buy it.
For $30, you can have a medieval weapon.
Perfect for your jousting adventure. What we got here? Oh, that's a while ago. Okay.
The lance is
The lance.
yes. Okay.
And now
so
our first one is a TV monitor.
less exciting. But interesting, they pulled a different JPEG again from train 0.
Was what I'm saying. Yeah, it switched again.
Does it randomly choose one? If you run that again, will we get a different one?
Oh, I mean,
So 2549.
You mean like that, or if we actually run the whole function again?
Run that block again.
So, but because this shouldn't change it, right? Yeah. So that's the same, but if we
run that whole thing, because I think it's just getting X, getting Y, right? Like it's.
Is it gonna?
If you run, can you run it?
Yeah, I can.
Yeah. Okay. So it's doing something there. I'm not super concerned about what it's doing right now.
Neither.
So to actually open the image and oh man.
What? What are you laughing about?
I just thought like we were worried about, like we were trying to figure out how to open an image before, but this is obviously not the same thing. But it's funny that it's the same along the same lines of like we're opening an image. Anyway, to actually open the image and do the conversion to tensors, we will need to use a set of transforms. Block types will provide us with those. We can use the same block types that we have used previously with one exception. The image block will work fine again because we have a path that points to the valid image, but the category block is not going to work. The problem is that the block returns a single integer, but we need to be able to have multiple labels for each item. To solve this, we use a multi-category block.
Aptly named.
Yep. This type of block expects to receive a list of strings, as we have in this case, so let's test it out. So dblock, okay.
Cool. Sorry for not removing the output.
I didn't look at it.
Good. This is ours. This is the real output.
Wow.
Okay, so we're making a data block, and the blocks we're using is an image block and a multi-category block. Get X, we use the functions we defined just up there.
Yep.
And then data block datasets, pass in the thing again, and then pick it out. Okay.
Okay. As you can see, our list of categories is not encoded in the same way that it was for the regular category block. In that case, we have a single integer representing which category was present based on its location in our vocab. In this case, however, we instead have a list of zeros with a 1 in the position where the category is present. Okay. For example,
so that's just
if there's a 1 in the second and fourth positions, then that means the vocab items 2 and 4 present in the image. This is known as one-hot encoding. The reason we can't easily just use a list of category indices is that each list would be a different length, and PyTorch requires tensors where everything has to be the same length. So this is my understanding, and correct me if I'm wrong, but this multi-category tensor is a list of every label, so it's getting all the unique labels. That length is the same length as this multi-category tensor, and then the position that's a 1 is what is inside of the image. Yeah, okay.
Yes.
Okay, so Jargon, one-hot encoding using a vector of zeros with a 1 in each location that is represented in the data to encode a list of integers. Okay.
To encode a list of integers? Why integers? All right.
Yeah, I don't know. Is encoding a list of integers just saying that we're using a vector of zeros?
But that's not even integers. That's like floats here.
Yeah, I know.
So
are you encoding? I don't know. Anyway, moving on. Let's check what the categories represent for this example. We're using the convenient torch.where function, which tells us all of the indices where our condition is true or false. Okay.
Wait, indexes torch, where the data set training set, the first one, 0, 1 equals 1. 0. It's a lot of numbers.
Yeah.
Symbol.
Train. Well, so is that getting the 0 item? And then Y is the label. Right?
So this is the label?
The first. So, but that's the second index in the label. How do you know there's more than one index? Unless I'm misunderstanding.
Wait. So I think this would be a value plus a label. We're getting.
Okay.
This is value plus label right there. So and then we're getting the label.
Right.
This is the label.
Where the label is equal to 1. And then, okay. I got you.
Okay. Interesting. And then this is a 0 because I guess this must. I don't know what this 0 does.
I feel like that 0 is the word dog, like that's the actual label.
But what's part of this other thing? Like what else would be there? I'm just gonna try that. What else comes if we don't do that? Same.
Nothing.
Right. So that's confusing. I'm not like. What I understand here is pick out all of the ones that have a 1 in the label, right? And then you're looking it up in the vocabulary. Which ones?
No, you're getting the first image in this training set, and you're seeing what the label is.
Yeah, right. Yeah, but the label could be more than one thing, right? It doesn't have to be just dog. It could be horse person. So I have the feeling this 0 means that it picks just one label. So, okay, so let's just check.
No, that's what I'm... So torch.where, right?
Yeah.
dsets.train 0, 1 is equal to 1. That, I think, is going to return the list, like the indices. And I think the 0 is... Oh, no. So dsets train.vocab indexes, that's where it would get.
That's just a lookup, yeah. That's like
where
in
it's
the
going to
vocab.
get the dog. Right, that's where it's going to say. Mm-hmm. Yeah.
I think this one is probably gonna be a list of all the names, right?
Yeah, so take the 0 out, that last 0.
And then let's try some other ones.
And pick like 10 or
yeah.
Mess around with it.
Interesting. Only one element tensor can be converted to Python scalar. So that's what's happening. Even if there were multiple categories, no.
Ah, okay.
Okay.
Oh, does it return back a
I guess let's look what it returns, huh?
Right, like what is type of index?
If we run it like that. So it's a tuple. Okay, interesting. So it just has the first item is actually all of the label positions, but then it has an empty second item. Like it's just a tuple with only one item, which is strange. Why?
Well, hold on. The tuple
seems to always just have one item, you see?
Yeah, but that comma is multi-category. That's the tensor, right?
Oh, you're right. Okay, so it's
so it's still
this
one,
is the object.
It's still one item tuple. Yeah. Is it tuple or tuple? What did we land on?
Tuple. Yeah, that's what we landed on. Okay, yeah, so you're right. It is a tensor multi-category object. No, there you go. This is what it's a tuple, and one of them is the tensor multi-category object, and the second thing is empty.
Right.
Yeah. I wonder, but it seems to always be empty.
Yeah, I don't know why it's empty.
It feels somewhat unintuitive, this.
I mean, it could be that it's empty because this is a very specific use case where torch.where on a different use case would utilize that second position. You know?
Yeah.
So
probably. Okay, I'm gonna keep this around because it's kind of interesting and remake what we had here before. Dsets, chain vocab, and pass it indexes. No category. It's like that, right? We're not calling it. We're slicing it. There it is. Bicycle person. 1020 bicycle person. Okay. I shall read. Is that fine for you?
Yeah, go for it.
With NumPy arrays, PyTorch tensors, and fast AI's L class, we can index directly using a list or vector, which makes a lot of code, such as this example, much clearer and more concise. We've ignored the column is valid up to now, which means that DataBlock has been using a random split by default. To explicitly choose the elements of our validation set, we need to write a function and pass it to the splitter, or use one of fast AI's. It is predefined functions or classes. And so, okay, so DataBlock does a random split and seems like it does a 80-20. And now we're saying if we want to be specific about it and use what the dataset suggests, then we have to pass it a function. We'll take the items here, a whole data frame. We must return 2 or more lists of integers. Lists of integers. Okay, train. Data frame is valid to list. Not is valid to list, and data frame is valid to list. Okay. So this, I think this little squiggly line says if it's the negated part of it. Okay, so that's our splitter. It says take in the data frame, make the training set everything that is false at the is valid column, and make the valid part everything that is true is valid. Then return both of them in a tuple. Bless you. And then, and again, DataBlock. And then we're passing additionally to get X and get Y, we're passing also the splitter. And then we're should have a training set that has the same sizes. What was that? The shape? No. Dataset train. Dset. Okay, wait, let's just do this. Dset. Train. Dset dot. Test? No. Valid? Is that how it goes? And he scrolls back to find out why. Length, this is what we want. Yes, these are the train, these are the values. And we want their length. And now it should be 2500, 2500-ish. Wow.
Yep.
Coming full circle here, huh?
Yeah, nice.
As always, trust the writing. Okay, but it's good. That means we understood this correctly and even had the right, you had the right intuition for what is valid is. I didn't. As we have discussed,
go for it.
Yeah, a data loader collates the items from a data set into a mini batch. This is a tuple of tensors, where each tensor simply stacks the items from that location in the dataset item. Now that we have confirmed that the individual items look okay, there's one more step we need to ensure we can create our data loaders, which is to ensure that every item is of the same size. To do this, we can use random resized crop. Okay, blocks, so we explained splitter, get X, get Y, the inputs, image block, multi-category block, and then now we're doing an item transform, which applies on each item before it goes into the batch, and there we're saying just to resize all of them to 128, 128. Cool. I get it. And now we can display a sample of our data. That's a nice picture of a dog. But we won't see that. We're going to see our own. Oh, we do see the same. That's so interesting. I wonder why. Remember this magic thing? How it always just displays 9.
Oh, that's right, yeah.
One day, I tell you, we will understand.
Yep.
Wow, those are some creepy pictures.
Cow, horse, person.
Chair, person. Interesting, you don't really see the chair. But it's true that they're sitting.
Yeah.
Or maybe not, actually. Maybe they're not. Maybe they're standing. I think they're standing. Is it classifying one of those people as a chair?
Is there a chair? Is she not leaning?
I don't think so. I mean, there is actually a chair. There's a wrapped up chair there in the back. Do you see that? It's like one of those wedding chairs or something that has like a band.
Yeah.
That's pretty good. So it's saying person, 2 of them, and then there's a chair.
Wow.
All right. Impressive.
Okay.
Cow, horse, person. Cow, horse, person. Bicycle, person. Car. Mountains. Bus, car. Person. Where's the person? There's the person. Chair, dining table. Look at that. It's a turkey.
We don't know that.
it did not classify the turkey. It's like so, but it probably is, right? If you look at the rest, what's on the table. They have a pumpkin here, so it's in autumn, probably. They have some wine.
This looks like a Thanksgiving.
Right? It does. So it's probably actually a turkey with some grease.
Oh, no, it's definitely a turkey. I'm just saying we don't know because...
okay.
Anyway.
Because it didn't tell us. And we don't know anything about turkeys, is that what you're saying? Okay, remember that if anything goes wrong when you create your data loaders from your data block, or if you want to view exactly what happens with your data block, you can use the summary method we presented in the last chapter. Our data is now ready for training a model. As we'll see, nothing is going to change when we create our learner, but behind the scenes, the fast AI library will pick a new loss function for us. Binary, cross, entropy.
Okay.
And what happens to binary cross entropy you can see next time. Or not. Should we go? We've only been going for an hour.
Yeah, how do you feel? I actually feel better than I did when I started.
Yeah, same.
So, totally
right,
up to you.
Let's do this. Let's do this. We can still stop any time later on.
Yeah.
But let's keep going.
All right, should we I'll read.
Yes.
Binary cross entropy. Now we'll create our learner. We saw that in open close bracket that a learner object contains four main things: the model, a data loaders object, an optimizer, and a loss function to use. We already have our data loaders, which we can leverage FastAI's ResNet models, which we'll learn how to create from scratch later. Okay.
Oh.
That's cool.
Mm-hmm.
And we know how to create an SGD optimizer. So let's focus on ensuring that we have a suitable loss function. To do this, let's use the CNN learner to create a learner so we can look at its activations. Okay, so learn equals CNN learner, ResNet 18. Got it.
Mm-hmm.
We also saw that the model in a learner is generally an object of a class inheriting from nn.module, and that we can call it using parentheses and it will return the activations of a model. You should pass in your independent variable as a mini batch. We can try it out by grabbing a mini batch from our data loader and then passing in the model.
Okay. I zoned out for a second, but it's fine.
Okay. Did you run that? Yeah.
Yeah.
Okay. Think about why actives has this shape. We have a batch of 64, and we need to calculate the probability of each of 20 categories. Okay. So that 20 is going to change based on how many categories it picked up, how many different labels.
Depending on the data set. Like this data set only has exactly 20 different categories. Yeah. Categories.
Okay. So actives 0. Let's run that.
So let's think about what it is. It has this shape. Actives has this shape. Okay. Here's one of those activations looks like. What's that going to be? I don't know.
Yeah, just a tensor.
But what does it mean? Is that 20?
Well,
probably.
No. This is no. We have this, and then we have to. This is the activations, so we have to now take this activation.
It is 20.
Oh, were you saying the length or the sum?
No, I meant
I thought you were suggesting the sum. No. The length is like this is now going to be the probability of each one, right? And we have to put these between 0 and 1, right?
Why does it have a probability of each one? I'm confused.
What I'm saying is, isn't it like it's saying that it's... So from what I remember, the activation function, we take this tensor and then apply it to like the sigmoid or whatever, so that we have a more balanced kind of like it's closer to 1, it's closer to 0, right? Like how far it is.
Yeah.
Right?
Wait, do you understand what these numbers mean? Is that what you're trying to explain to me? Like, what is this -2?
Yeah,
because I don't understand.
We've gotten these before, and then I believe if we scroll down, the next step is applying the sigmoid function.
Yeah, probably. I just still not. Okay.
So right, these are calculating the loss, right?
Yeah.
Hold on. Getting model activations, knowing how to manually manipulate. Okay, that's not it. These aren't scaled between 0 and 1, but we learned how to do that in blank using the sigmoid function. We also saw how to calculate a loss based on this. This is our loss function from blank with the additional log as discussed in the last chapter. So
yeah, I guess I didn't really understand this loss function thingy. Anyways.
So minus torch where targets .log.mean. Okay, note that because we have a one hot encoded dependent variable, we can't directly use NLL loss or softmax, and therefore we can't use cross entropy. Okay. Softmax, as we saw, requires that all predictions sum to 1 and tends to push one activation to be much larger than the others due to the use of exponential.
Mm-hmm.
However, we may well have multiple objects that we're confident appear in an image, so restricting the maximum sum of activations to 1 is not a good idea. But the same reasoning, we may want the sum to be less than 1 if we don't think any of the categories appear in an image. NLL loss, as we saw, returns the value of one activation, the single activation corresponding with the single label for an item. This doesn't make sense when we have multiple labels. Okay. So, on the other hand, the binary cross entropy function, which is just MNIST loss along with log, provides just what we need thanks to the magic of PyTorch element-wise operations. Each activation will be compared to each target for each column. So we won't have to do anything to make this function work for multiple columns. Okay.
One of the things I really like about working with libraries like PyTorch with broadcasting and element-wise operations is that quite frequently I find I can write code that works equally well for a single item or a batch of items without changes. Binary cross-entropy is a great example of this. By using these operations, we don't have to write loops ourselves and can rely on PyTorch to do the looping we need as appropriate for the rank of the tensors we're working with.
PyTorch already provides this function for us. In fact, it provides a number of versions with rather confusing names. f.binary cross entropy and its module equivalent NN-BCE loss. Binary cross entropy loss calculate cross entropy on a one hot encoded target, but do not include the initial sigmoid. Normally, for one hot encoded targets, you'll want f.binary cross entropy with logits, or BCE with logits lost, which do both sigmoid and binary cross entropy in a single function, as in the preceding example. The equivalent for single label datasets like MNIST or the PET dataset, where the equivalent for single labeled datasets, where the target is encoded as a single integer is f.nl loss or NLL loss.
nn.nll odds. nn.nlloss.
Yeah.
That's fun. It doesn't have a lot of different characters in there.
For the version without the initial softmax, and f cross entropy or nn cross entropy loss for the version with the initial softmax. So since we have a one hot encoded target, we will use BC with logits lost. Logits.
Okay. Sure.
Yeah, right.
All right. I'm noting for myself. Martin, you don't understand loss functions. Note. Okay. Keep going.
We don't actually need to tell FastAI to use this loss function, although we can if we want, since it will be automatically chosen for us. FastAI knows that the data loaders has multiple category labels, so we'll use NNBC with log gets lost by default. One change compared to the last chapter is the metric we use, because this is a multi-label problem. We can't use the accuracy function. Why is that? Well, accuracy was comparing our outputs to our targets like so. Okay. Compute accuracy with target when prediction is BS times n classes. Okay. The class predicted was the one with the highest activation. This is what argmax does. Here it doesn't work because we could have more than one prediction on a single image. After applying the sigmoid to our activations to make them between 0 and 1, we need to decide which ones are zeros and which ones are ones by picking a threshold. Each value above the threshold will be considered as a 1, and each value lower than the threshold will be considered a 0. So accuracy multi. Okay, so this is kind of like what we were sort of thinking in the beginning.
A little, yeah.
Yeah.
Mm-hmm.
Which is
like
kind
there
of nice.
Seems to be some threshold.
Yeah, which is kind of nice because it's like not as much magic as we thought it could be. If we pass accuracy multi directly as a metric, it will use a default value for threshold, which is 0.5. We might want to adjust that default and create a new version of accuracy multi that has a different default. To help us with this, there's a function in Python called partial. It allows us to bind a function with some arguments or keyword arguments, making a new version of that function that whenever it is called, always includes those arguments. For instance, here's a simple function taking 2 arguments. So say hello. So messy the way that they write functions.
Let me clean it up. So here you're calling it.
Really, like, why couldn't they just put this?
I thought, I mean, this part, one of the reasons here is because, so he's printing out a tuple actually, because otherwise you'd have to do this if you want to see both outputs.
Got it.
Right? Yeah.
Okay, we can switch to a French version of the function using partial. Oh, I thought that's silly.
Function. Okay, so it's partial. So that it always takes. Wait. Hell. Okay, so it takes the different default. Okay, I got it.
Yeah.
So we're saying take the same function, but instead of that default. Yeah. So the arguments you can pass in. Interesting.
I mean, wouldn't
I haven't worked with partials at all myself in Python. I think I've heard about it, but I've never used it in practice anywhere.
I
mean, it's kind of fun.
Wouldn't I'm trying to think like how.
I wonder if we can also pass name. I mean, probably, right? We could choose one of them. So I can say Nick, and I could say what? Guten Tag. And then if I now pass something, is it going to fail, or is it just going to say, it's just not going to care? Yeah, interesting. So it fails because it already gets this one automatically supplied, and I'm giving it again. So I could call it without an argument, and it's going to take the 2 ones. Yeah. Interesting. And this, what happens if I don't give, if I just pass them like that?
Oh.
that gonna work? Or do I have to specify? Or it just takes it, yeah. So it just takes it.
It's nice,
default.
I guess, like it's nice to specify, because in this case,
Right, yeah. But it's essentially like calling the function, right? You're calling the function, but instead you're passing it to partial with the comma, yeah, and then the arguments, depending on however, like you could call them with keyword arguments, or you could just pass them locational. Interesting. Yeah, okay. Guten Tag, Nick. We can now train our model. Let's try setting the accuracy threshold to 0.2 for our metric. Learn equals CNN learner data loaders ResNet 50. Look at that. Metrics partial. Interesting. So yeah, so now we're just passing. Interesting. Partial accuracy multi threshold 2. What was the accuracy multi otherwise? Input target threshold sigmoid 2. Okay, and we want to keep the rest as it is. We just want to change the threshold. Cool. All right, so this is some learning here. Let's start it. We're doing a ResNet 50, so it might take a little. Maybe also not. What do I know? What do I understand about this? Not much. I know we need a GPU. I understand as much. Pretty good, huh? Seems to be going quite swiftly.
Mm-hmm.
Look, so we got some, so we're using fine tune again. And the first one is 3, meaning keep freeze epochs run for 4 epochs with the original stuff frozen, meaning you just train the later layers, I believe, and then unfreeze everything and do 3 epochs of training where you adapt all of the values, I believe. I think that's what we concluded. Maybe I'm mixing it up, but I think that's where it was.
So you're saying it's freezing 3 layers, and then it's freezing.
It's freezing 4. No, it's doing it's doing 4 epochs on while the original ResNet 50 is frozen. So which essentially then just trains the new layers with the frozen values of the original ResNet, and then it unfreezes it, and then it trains 3 more epochs using like adapting the weights throughout the whole architecture. I think
I need to go review the lesson that we did with Gilad.
So for where it did maybe with the frozen one, and now it's going to do 3 epochs training the whole. So this should be a bit slower. It's still going pretty quickly.
Yeah, it's still going pretty quick. So now it's going to train 3 epochs. So it did 4. Now it's going to do 3. Okay.
Picking a threshold is important. If you pick a threshold that's too low, you'll often be failing to select correctly labeled objects. We can see this by changing our metric and then calling validate, which returns the validation loss and metrics. Validate. Interesting. So after you trained it, you can still pass an different accuracy threshold in there. 0.1, 0.9. I don't know what that means. If you pick a threshold that's too high, you'll only be selecting the objects for which your model is very confident. So here it's going to find everything, and here it's going to... But what does this output mean?
Let's see. You'll often be failing to select correctly labeled objects. We can see this by changing the metric. Okay, so if the threshold is super low, right, this 0.1.
Yeah, it's gonna be happily it's gonna classify a lot of stuff, even though it shouldn't.
So it returns the validation loss and metrics. If you pick a threshold, okay, we can find the best threshold. It's kind of confusing because the numbers are very similar.
Yeah.
Right? In the first case,
I don't understand what that's
the
about.
loss is exactly the same, and then the second, the threshold is like.
Oh, so is that loss and accuracy or what? I've already forgot that.
It says loss and metrics, which return the validation loss and the metrics. So the loss
and metrics.
The loss is the same, but I don't understand why what the metrics are and why it's very similar. Okay, so that
I think the metrics in this case is this multi-accuracy, right? Like it's not in the other one we had like accuracy,
but it's not
what we're aiming for.
It's not retraining, it's just validating. It's working on the validation set.
And it's just telling us that we're getting a different outcome. Like this is a 93% and this is 94%.
Yeah, can you change it to like 0.5 or what the default is so we can see?
Well, let's actually check what our values are.
Sure. Yeah, that's valid. Okay, so it is running through that again.
Well, it's running through the validation set. Just check. Yeah. And then we said our threshold is 0.2. Okay. And what was our outcome? 0.95. I guess that's what we got, what we ended up with, right?
Okay.
I think maybe that's on train. So let's try.
Okay.
So it's just telling us that we get worse. What was it? 0.2? Yeah. Worse both if it's too low and if it's too high. Mm-hmm. 0.95087.
Yeah, that's better.
Yeah, that's the one. That's the one we ended up with here. Okay. Yeah.
I don't think I fully understand it yet, but
blah, 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 blah. Let's move on.
Yeah. We can find the best threshold by trying a few levels and seeing what works best. This is much faster if we just grab the predictions once. Okay.
Otherwise, it was doing that every time.
Yeah. Then we can call the metric directly. Note that default get predictions applies to output activation function, sigmoid in this case. For us, we'll need to tell accuracy multi to not apply it. So accuracy multi predictions targets threshold 0.9 sigmoid false. Okay.
And 566.
We can now use this approach to find the best threshold.
Lint space 0.5, and then we're plotting it. Nice. Looks like it's somewhere here between 0.
Well, really, just anywhere between
and 0.7, yeah.
5
0.4 and 0.7.
So 0.6 seems good. So let's you want to go up and rerun it because we're actually over this one. So
I just ran this one.
No, I know, but the cell right above this one, copy that.
Yeah, okay. And then we try with 0.6. Wait, we're probably gonna do that. 0.6 seems good, right?
Yeah, I just want to compare it to that like 0.95. Okay, so 0.96, pretty good. So in this case, we're using the validation set to pick a hyperparameter, the threshold, which is the purpose of the validation set. Sometimes students have expressed their concern that we might be overfitting to the validation set, since we're trying lots of values to see which is the best. However, as you see in the plot, changing the threshold in the case results in a smooth curve. So we're clearly not picking some inappropriate outlier. This is a good example of where you have to be careful of the difference between theory, don't try lots of hyperparameter values or you might overfit the validation set, versus practice. And this relationship If the relationship is smooth, then it's fine to do this. This concludes the part of the chapter dedicated. Okay, next we'll take a look at regression problem. Go up a bit. I want to just mess around with that graph a little bit.
Sure. Do you want to do it actually, or do you want to do it by controlling my mind?
No, I'm going to control your mind, and then you're going to do it.
Okay.
Because you know the API better than I do. Can you... Can you plot the graph between 0.4 and 0.8?
Maybe. What do you think is... So this is 0.05. I don't think I can.
Yeah, so just change that to 0.4.
Yeah, we're starting here, and then what's this 29? You think 29 steps? Yeah, make 29 values probably. And 0.7?
Or 0.8.
Okay. 29, let's skip that. I don't know what the 29 is.
Okay, so I'm just trying to see, like, because it looked like it was kind of messy a little bit here. So I want to see, like, you know, these peaks and valleys. So the highest point, which is interesting because if you, yeah, it'll start smoothing out a bit more.
Okay. So we're somewhere between, let's see that. Woo.
So 0.575 seems pretty good. Can you...
So would that mean we're overfitting if we do this? Is that what he's talking about?
Oh, look, what's interesting is we picked 0.6, and right after that, that's that valley. So if we picked 0.575, or
we should get a better accuracy. Yeah.
Can you print the value, the highest value? Do you know how to do that?
No.
Excess torch.linspace. What is excess?
Just trying like that for now.
Yeah.
Yeah, it's a little higher.
638, yeah. What is the
X? I guess so. It would be in x-axis.
Yeah, XS.
Okay. Axis. Let's see what that is. Maybe we could figure out what's the highest value. It's a list. Well then, I think we should be good. I wonder.
No, XS.
XS. XS is the one.
Well, access 0.7.
That's something else.
That's not true. Yeah.
That's just that's the highest value here.
Oh,
that's the value we're passing in here. Yeah.
Oh, so go into
something
axis.
else that gets made in this.
No. Go to axis. Highest value axis.
This.
Yeah,
this?
yeah. Scroll down a bit. So change that to axis again. And if you run that, we get 9.3 whatever. Can you do...
Oh, yeah. Look, that's it.
Yeah.
That's the highest value. And now we just need to know
I know, we don't have to like
from.
retrain it. Right. So can you do like... So since that is the highest value there, how do you get the x-axis to that? Because this is the highest y, right?
Yeah, I think you're right.
So can you do XS? Because XS is just
show the whole thing, you mean?
Well, yes. So now
and now we see, and then x-axis is also going to be a tensor multi-category, and then the highest one. So we could see max x, and then x dot index max x. You like how that sounds?
Yeah,
and then we can say axis 11, or we can also be more exciting and do this. Here we are, 5.786.
Yeah. Okay.
So that would be it. That's the highest, at least from those values that we got in the way that we were splitting it up. This should give us the 963839.
39. Yeah. I feel like I learned more in the last part of this than I did in the beginning, like tying everything together and experimenting.
Great.
Yeah. Okay. Cool.
Are we finished or what?
Yeah,
Regression?
we're on regression now.
Oh, cool. Yeah, and then nice. Yes. So this we do next time, huh?
Yep.
Wow. Cool. Yeah, that's ended up being like pleasant and productive, huh?
Yeah.
Who would have thought?
Who would have thought? Sub 2 hour streams, pleasant and productive. Yeah, no, this was good. Do you want to review anything? Do you want to?
Sure, do it.
No,
I want you to review it.
I'm asking if you want to review anything.
All right, let's see what it tells us, what we went over. Okay, so let me give it a try. Review. Okay, we talked about other computer vision tonight. We talked about other computer vision problems and decided that there's two distinct things from each other, one being multi-label classification, the other one being regression. We said regression next time. Let's not talk about it much, but I think it said, I actually forgot what it said. It was surprising. Quantity. So it says that regression is for predicting for getting the quantity of objects somewhere. We'll see about that.
Yeah, I don't know if that's really the case. It was very like our brief interpretation.
Yeah. We'll see about that next time. But this multi-label classification was, you want to know what a horse person looks like, then you can use this one. And bad joke. What is it? It's like you have an image and you want to find like a couple of different things on that image. For example, a horse and a person and a lance. If that's one of your labels.
Sure.
Cool. Then we learned some stuff about pandas and DataFrames. What was interesting about that maybe is that you can slice them in a similar way that we learned how to slice tensors previously. Like it's again this column row syntax, I think, and with the normal Python slicing syntax. And then we looked a little. I guess we started looking at the data. We got confused about is valid. Turns out it really is a definition of what should be in the validation set and what shouldn't be. We figured out how to get to these images and learned something about a maze and a lance. Then pandas, talked about that just now. And then we looked into data blocks, what to do with data blocks, and drizzle that apart a little more. This was confusing, but now it's all clear. It's when you make a data block data set, by default it does a valid train split unless you define specifically that it should be doing it differently. So it does this by default, and later we did it in that way by using the value that was provided in this CSV file.
Can you run that block again? The one above
Which?
length?
This one?
Yes.
Sure. Why?
And then run length again?
Should be the same.
No.
Because it's in the...
Yeah. Never mind.
It's the data block, right? We changed the data block, right?
Yeah. Can you try it again? Change, like re-initialize.
If I run this?
Yeah.
Then it should be...
And then
similar.
try. I think you have to run again, right?
Oh no, I changed it.
Okay. Because it said it splits it randomly, but in this case it split it exactly the same.
Did it really say randomly?
I believe it said random. Yeah.
Has been using a random split. Yeah, I think random split just means which which data items go into which batch. That's the randomness, not
But it's
how much it is.
Got it. Okay.
Yeah, it
So it's
keeps
doing the
ratio
80-20
the same.
ratio, but got it.
Yeah.
Okay.
Where were we? I mean, I'm not sure. Is it actually 80-20?
Yeah. It's
Do
close.
you see that?
I mean, out of 5,000, 20% is
How do I do
1,000. Huh?
that? Length.
What are you trying to do?
This divided by.
Oh boy.
That works, right? Is there an easier way to do it? I guess. Do I have to do times 100? No. This divided by 100 times this? Is that all wrong? Wait, what was I trying to do?
So
Is
it's
it
the other way. You
divided by
you divide that. So take that and throw it in the front.
what? This
divided by that.
That times 100 if I want.
Yeah, sure.
Okay.
Yeah, so that's
okay.
20.
Nice. So that's nearly 20, yeah. Cool. So that's the default 80-20 ish. 80-20 split default. Okay. What else? Anything else? Binary cross entropy. Yeah, also binary cross entropy. And that's okay, Nick, you gotta do that. I don't know what this is all about. You got anything to sum up here?
No.
You can scroll if you want.
No, I don't have anything to sum up here.
So that's some loss function. It's a different loss function because we're using multi-categories.
Yeah. If you scroll down a bit more, right there. So right, because we're doing one hot encoded dependent variables, you want to use the my brain is definitely fried. So we can't directly use NL loss or softmax, and that was because softmax sums it to 1, and sometimes we want to have multiple, because we're trying to get multiple, determine if multiple things or classifications are in the image. We can't have it sum to 1. It was my understanding. So we can't use softmax.
Okay.
And because we can't use softmax, we can't use the regular cross entropy because that's built in.
So we got to do something with a lot of same letters.
Oh, yeah.
No, we're not doing that one. That's just the example. I'm just being stupid. We got to do some binary cross entropy with logits instead. And we can have that run like that's. It also does it automatically, it seems. Oh, look at that. It's true.
Yeah. Yeah. So I think
one day
we'll learn it.
Okay. I think you're about to be arrested, Nick, so maybe we should end the stream here.
It's quite loud here. It is. I don't know what's happening. But yeah,
right,
I think
good.
we did. This was pretty good. I think we definitely don't have like a great handle on multi-label classification, but I think we'll further understand it when we build something next Thursday.
Cool. So Monday we're going to do a regression, the second part, figure out whether we can actually quantify how many apples are in one picture.
Yes.
Homework, get a picture with some apples on it from the internet.
All right, fair enough.
And then we figure that out.
All right, so we'll see everybody on
Peace.
Monday. Yep. Bye.
Bye.